Welcome back to Calculus. This is part 12. In this video, we will discuss a beautiful question from rate of change, application of calculus. Alright, let us look at this question on rate of change. A beautiful question. Bongani throws a ball into the air from the branch of a tree. He is not on the ground, he is on the branch of a tree. The height of the ball above the ground after t seconds is given by the equation, a function in t, st equal to minus 4t square plus 19, 2t plus 4 meters. Question A, determine the height of the ball above the ground after 2 seconds. So it's not a problem for us because we have the equation to calculate the height and we have the time in the question, 2 seconds. We substitute very carefully and then we use the calculator and we get the answer. That is 26,4 meters. So what we understand, the height of the ball above the ground after 2 seconds is 26,4 meters. Question B. Determine the average speed of the ball during the first 2 seconds. What is the meaning of average speed? The ball is moving. It starts at 0 seconds and then it is up to 2 seconds. There can be different speeds during this interval. So here is the average speed between 0 seconds and 2 seconds. That is our question. Now, what is the definition of speed? Total distance traveled divided by total time taken. How do we calculate the total distance? We already have the equation for the height or distance. St equal to minus 4t square plus 19, 2t plus 4. At 0 seconds, the time is 0 seconds. The distance or the height, we substitute 0 in the place of t and we use the calculator, we get 4 meters. That is the height of the branch where Bongani is sitting. Now, what is the distance after 2 seconds? The time is 2 seconds. We substitute 2 in the place of t and we calculate using the calculator. We get 26,4 meters. That's the distance of the ball after 2 seconds. So the total distance we can calculate, that is 26,4 minus 4 divided by total time, that is t2 minus t1, 2 minus 0. When we use the calculator, we can get the answer 11,2 meter per second. That is the average speed. Question C. When will the ball be at a height of 26,4 meter above the ground? Look at the diagram. The ground and the level 26,4 meter. In question A, we already calculated the height after 2 seconds and we got 26,4 meter. But that is not the only time. Let us look at the movement of the ball. Look at that. The ball goes up, going to the maximum height and coming down. So after 2 seconds, it reaches 26,4. Again, when it comes down, when it returns, another time is there. So that is what we have to calculate in this. So we have the equation for the height, and the height is available, that is 26,4. We substitute into the equation. Now we try to solve for t. This is a quadratic equation. We have two values for t. Simplifying and writing the standard form, t square minus 4,8 t plus 5,6 equal to 0. Okay? We make use of the formula here, substituting very carefully into the formula and using the calculator. We get t equal to 2 seconds or t equal to 2,8 seconds. Look at that. After 2 seconds, the ball reaches the height 26,4. Then it moves up, going to the maximum and coming back. Look at that. Again, 2,8 seconds. After 2,8 seconds, it is still at the height of 26,4 meters. So that is why we get two answers for T. Okay. Question D. How long will it take for the ball to reach its maximum height? A question of 3 marks. How long? Meaning we have to calculate the time. The ball reached its maximum height. Okay, we come back to the topic maximum or minimum, and we are going to apply the calculus here. We have already learned at the maximum. Maximum is a turning point. The first derivative will be equal to 0 at the maximum. So that is the calculus application. We have the equation to calculate the height. It's given in the question. We find the derivative at the maximum. S dash t must be equal to 0. The gradient at the maximum point of the curve will be equal to 0. That is S dash t equal to 0. What is S dash t? Minus 8t plus 19,2, which is equal to 0, and we solve for t. We get 2,4 seconds. Meaning after 2,4 seconds, the ball will reach its maximum height. Now the question continues. Determine the maximum height. We already calculated the time to reach the maximum height. Now what we do? We just substitute 2,4 into the equation to get the maximum height. Substituting very carefully and using the calculator. Simple as that. We get 27,04 meters. Hope you understand. The maximum height is 27,04 meters. Another question of 3 marks. After how many seconds will the ball hit the ground? Okay. Look at the diagram here. After how many seconds it will hit the ground from the starting. We have the equation already. The ball hit the ground, but the height at the ground is 0 meters. ht equal to minus 40 square plus 19,2 t plus 4, where the height is 0. 0 equal to. So we solve for t using the formula. We substitute very carefully and use the calculator. We get t equal to 5 or t equal to negative 0,2. That negative answer is not applicable here. Okay. So after how many seconds? We can say after throwing the ball, after 5 seconds the ball will hit the ground. Another question of 3 marks. At what speed was the ball traveling at the moment of impact? At the moment of impact means at the time when it hits the ground. So here the question is to calculate speed. Now we have the equation and speed. We apply calculus. That is the first derivative, h dash t, which is minus 8t plus 19 comma 2. Now h dash of t, what is the t here? What is the time? It's 5 seconds. Substituting 5 in the place of t, we get minus 20,8 meter per second. The answer is speed. Now we have a negative sign there. What does it represent? Look at this. The ball is falling downward. That's why we have the negative sign. Now our answer is the speed at the moment of impact equal to 20,8 meter per second. We don't mention the negative sign in the answer. Finally, another question of 2 marks. What was the velocity of the ball after 2,4 seconds? Velocity, the speed, that is h dash t. And we substitute 2,4 into the derivative, we get 0 meter per second as the answer. Okay, so the velocity at 2,4 seconds, that is at the maximum time, maximum height, we calculated 2,4 seconds, and at the point, the maximum point, the stationary point, the velocity is 0. That is the explanation. So that is the end of part 12, application of calculus. Try to practice more questions from the past exam papers and score from this rate of change questions. Okay, good luck.